Linear and absolute value inequalities. So, what is an inequality? An inequality is simply just a mathematical statement that compares two quantities and states or establishes that two quantities or expressions are not necessarily equal. An inequality can be expressed using any of the following six, let me not say five inequality signs right here. One, two, three, four, five. And I'm sure you have seen all of these before. X less than 3, or you can read it also as x is strictly less than 3. X is less than or equal to negative 1. X is larger or bigger or strictly greater than negative 3 eighths. So we sometimes throw in the word strictly to emphasize that the possibility of equality is not allowed, is not included. When you want to be like super sure that the message, when you read it out loud or write it in words, that the message is clear, that you're not allowing equality as a possibility. So sometimes you throw in the word strictly for emphasis. All right, and here's the last example: x bigger than or equal than 0.75, or greater than or equal to 0.75. So those are like single inequalities. All these four are examples of single inequalities. Sometimes we have compound inequalities, which are like when you have two or more inequalities taken together at the same time, simultaneously. Um, and these four right here are examples of compound inequalities. Sometimes I like to calling them like double inequalities, or like I mean that's just me. Double inequalities or sandwich inequalities, because it's kind of like more intuitive to see what's going on. Like x, like here x is sandwiched between 3 and 5. So I sometimes call them like that, but the like the correct mathematical term is compound inequality. Okay, so here x is bigger than or equal than than 3 and less than or equal than 5. Here you have x bigger than negative 7 and smaller than negative than 1, or you can, I mean, strictly speaking, you should read this: x is greater than negative 7 and less than 1. Okay, and you have all these. So you see you can have all possible. There's four types of combinations. You could have less than or equal on both. You could have strictly less than both. You could have one strictly less than the other one less than or equal, or less than or equal and the other one strictly less. So you have, when you have a compound inequality, you have four possible combinations. And again, uh, most examples are like two inequalities taken together, but you could have more than two. Okay. The solution set of an inequality is the set of all values that make the inequality true. So this is the set of all values of x for which the inequality is true. So in this case, is all the values, all the numbers that are between negative 7 and 1, not including negative 7 or 1. Okay, and when we solve an inequality, we usually express the answer in sometimes in inequality notation, but often we write it in interval notation, sometimes in set theoretic notation, and sometimes even in terms of pictures. So in interval notation, so these are the different possibilities. So we use intervals when we don't want to include the endpoints, the extremes. So if you have the interval a, b, and you use parentheses on both sides, that means um, you want all the numbers strictly between A and B, not including A or B. And when you draw a picture, some books use this kind of picture where you have like a dot that is not filled in, that is a hollow dot on both ends. That would mean that neither of the endpoints is um, allowed, is part of the, neither of the endpoints is part of the interval, and when you want to include them, you fill them in. Some other books, which is the case with some homework online assignment, with some online platforms like Hogs, Learning, or WebAssign, they might use um, slightly different way of drawing the picture. If this is like one way where you don't include the endpoints, um, some books use this notation instead. So instead of drawing hollow dots, they actually use the same notation as the interval notation, which is good. I like that. Because then the picture looks exactly like the interval. So if you're using the dot notation to include one interval, let's say I want to include the endpoint 3. By the way, this is a less than x less than a, bigger than a less than b. So as a concrete example, suppose I want to include this one. This is 5, 3. So I'm not including the 3, but I'm including the 5. So the 3 is hollow and the 5 is filled in. So this would be the interval 3, 5, and then you use parentheses for the 3 because you're not including it, and you use a bracket, a square bracket for the 5 because you are including it. So in the dot picture notation, it would look like this. In the other way of drawing this, you use the exact same notation as the interval. So if the interval has a parenthesis on the left, you use a parenthesis there, and if it has a square bracket on the right, then you use a bracket there. Which again, I really like this one because then it looks exactly the same as the interval. The picture looks exactly the same as the interval. Parenthesis on the left, bracket on the right. And this will stand for the set of all numbers between 3 and 5, not including the 3, so bigger than 3, and including the 5, so less than or equal to 5. Okay, and you have all these different combinations. As you can see, there's a bunch of them. I'm not going to go through each and every one of them because once you understand that you use parentheses when you don't want to include and you use square bracket when you want to include, then you pretty much have it. Okay, so let's go over each of these examples, and for each of these inequalities, we're going to represent them either as an interval and also graph them, okay, draw a little picture for them. Okay, so this is a set of all numbers between 3 and 7. So in interval notation, you would include the 3 because it's allowed, so that means you use a bracket. And you do not include the 7, so that means you use a parentheses. And that would be the inequality in interval notation. In terms of the graph, well, you draw your real line, so I'm going to draw it here with a pen. You draw a real line, then you write the numbers 3 and 7 on the line. I recommend that you avoid the temptation of drawing any other tick marks that is not either of these numbers. So don't draw 0 or 4 or 5 because it's not either of these numbers. And adding more tick marks than necessary is just gonna usually mess you up. Okay, so I want 3. So make it look like that. Square bracket on the left. And on the 7, I want parentheses because I don't want that. And then you want all the numbers inside. And there you have it. That's the picture for that inequality. Okay, now let's draw the picture for this one. All the x's between -2 and 4. Okay, first, the inequality notation is going to be, you want to include the -2, so parentheses for the -2, and then for the 4, you want to include it, so square bracket there. And now let's draw the picture. Draw your line, your real line, and only draw tick marks for -2 and 4. and resist the temptation of drawing any more tick marks because they're unnecessary and just not needed. So don't add them. Okay, so just those two, and then you don't want to include -2, so draw a parenthesis there. And you want to include 4, so bracket there. And you want all the numbers in between. Okay, so that's the picture for that inequality. That's the graph, we call it the graph. Okay, now let's draw pictures for the other two. The other two are not compound inequalities, just single inequalities. All right, so this one says all numbers to the left, smaller than 2. Smaller, get used to thinking of this. Smaller means to the left of. So x less than 2 or x smaller than 2 means all numbers to the left of 2. So when we draw the picture, oh, these markers are good. I mean, when you draw the picture, we are going to draw a tick mark for 2. Again, don't draw any more tick marks. They're not needed. And you don't want to, and you want all numbers smaller. Smaller means to the left. I'm going to draw here a parenthesis because that's not included, and I want all numbers to the left. So that's what that graph is going to look like. In interval notation, the right hand side is going to look just like that. Parentheses. I want a parentheses on the right too. And then to say that you want all numbers to the left of that, you use the infinity symbol. You keep going to the left forever. So to all the negative numbers minus infinity. And then when you use a negative infinite symbol, you always use a parentheses. Because you're not including a negative infinity. Negative infinity is not a real number. So you're never wanting to say you are including it because it's not a real number. Okay, then the last one, how would you draw that one? And what would be the notation, interval notation for that? This one says all numbers greater than or equal to -4. Greater means to the right of. So that means, and you're including it, so that has to be a bracket. So bracket, square bracket, -4, and then to the right, all the numbers to the right, so it would be to infinity. Okay, and then the picture for that, the graph, oh, I keep forgetting, I need to move that one away. The graph I'm going to draw only one tick mark for -4 because that's the only number that I'm seeing. And I want to include -4. So I'm going to draw a bracket. And I want all the numbers to the right of that. And that would be the picture for that one. So intervals like this go by a special name. They're known as infinite intervals or unbounded intervals. Infinite intervals or unbounded intervals. Okay, now we would like to go in the opposite direction and go from the interval notation to the inequality notation and the graph notation, the graph on a number line. Okay, so from this interval says parentheses -5, comma 8, square bracket. So that would be all numbers x bigger than -5 and less than or equal, because there's a bracket, means x could be equal to 8. So that would be the inequality notation for that one. And the picture, we should draw the picture. Okay, so I'm gonna draw a tick mark for -5 and a tick mark for 8. And remember, don't draw any more tick marks for any other numbers except the numbers in your interval or inequality. Okay, I want all numbers between -5 and 8, not including -5, but including 8. So not including -5 means you do a parenthesis there. Including 8 means you draw a bracket there. So it should look like your actual interval. Parentheses on the left, bracket on the right. And I want all the numbers in between. And there you go. That's the picture. Now you should pause the video and draw the pictures for the other ones and the inequality notation for both, for all three of them. Okay, let's do that. So this one is going to be in the picture. There's two tick marks, 0 and 4, and I want all numbers in between. Bracket on the left at 0 and parentheses on the right, just like that. And then you want all these numbers, and then in inequality notation, that would be all numbers sandwiched between 4 and 0, but I want to include 0, so x bigger than or equal to 0 on the left. Okay, the last two are examples of unbounded or infinite intervals. So this would be all numbers bigger than 4 or equal. Bigger than or equal to 4. Okay, so normally we do not write that inequality like this. It is not wrong to do that. But in college algebra, we typically don't do this. If it's just infinite on one side, we just don't write it. Okay. So we just say x bigger than or equal than 4, or like that. So both of these are actually correct. Both of these are correct. They are the same thing. Okay. All right. And then the picture would be I only see one real number in the inequality or in the interval. So I'm just going to draw one tick mark for it. And then my picture is going to look a bracket right there. And I want all the numbers to the right, bigger. Bigger than or equal to 4. So to the right of 4. And lastly, the last one is going to be so this picture right here. So one tick mark for -5. No other tick marks needed. You need parentheses there because it's not included. It should be like in the interval. And you want all numbers to the left all the way to -infinity. And in inequality notation, that would mean all numbers smaller than -5, not including -5, smaller than -5. So x less than -5.